Guys, we have a circle that's growing in such a way that the radius of the circle is increasing 2 inches per minute. As the radius increases, the area also increases. How fast is the area increasing at the instant that the radius is exactly 10 inches? To find this is going to require some calculus. First thing that they are telling us is that the radius is increasing at a rate of 2 inches per minute. So that's going to be dr dt equals 2. This is the change in radius over the change in time. Now the question is asking, what is the change in area over the change in time at the instant when the radius is equal to 10. So to solve this, we start with area equals pi r squared, and then we're going to take the derivative of both sides of the equation. On the left-hand side, it's just dA dt, but on the right-hand side, we need to use these 3 derivative rules. First thing is constant multiple rule. It says if you have a constant being multiplied by your function, that constant can just be brought out. So this pi is being multiplied by our function, so we're just going to bring the pi out. Next is the power rule. It says this 2 right here, we pull it in front, and then we reduce it by 1, giving us just r to the 1. And the last is the chain rule that says if you have a function inside of a function, you also need to do the derivative of that. In this case, we have this r inside of the squared function, so we need to take the derivative of that as well. So that'll be dr dt. Now on the right-hand side, we can plug in 10 for the r and 2 for the dr dt. And on the left-hand side, we can't plug anything in because this is what we're solving for. To clean this up, 2 times 2 times 10 is 40, and then the pi is still there. To give it a label, this is the change in area over time. So it'll be inches squared for area and minutes for time. And then we can plug it into a calculator to get approximately 125.66 inches squared per minute. That's the rate that the area is increasing when the r is equal to 10.